Hello everyone, welcome to day 9 of this machine learning internship, and we will be seeing about the visualization libraries, which is going to be Matplotlib and Seaborn in this class. So let's get started. Till now we have seen Pandas, Numpy and an exploratory data analysis project with Pandas. Once we complete this Matplotlib and Seaborn in today's class, in the next session it will be an exploratory data analysis which includes all Pandas, Numpy, Matplotlib and Seaborn, and with that project we can wind up our exploratory data analysis part and move into step 2 of our machine learning agenda. So we'll get started with Matplotlib first and then proceeding with Seaborn. So what is Matplotlib? Matplotlib is a graph plotting library in Python that serves as a visualization utility. So similarly we see many libraries, right, about Pandas and Numpy. Similarly, this is another library which is used for visualization purpose. So in this Matplotlib, we are having a module which is named as PyPlot, and this will make, it has many features and it is making the plotting very easy for us. So with the help of this Matplotlib, we can create many visualization reports such as line plot, scatter plot, histograms, pie chart, bar chart, box plot and many different types of plots. So let's start with this Matplotlib and let us see how it is useful in the data science part. And first step is the installation. To install Matplotlib, you have to type pip install Matplotlib. Okay, I'll type this in Google Colab, the exclamatory mark pip install Matplotlib. I'll run this. I already have this library, so it is telling requirement already satisfied. So the next step will be importing the Matplotlib. So Matplotlib is a collection of a lot of modules, and in that we will be using majority about PyPlot only. So what we are going to do is, we are not going to import the entire Matplotlib. We are going to just call the PyPlot module from this Matplotlib. For that what we are going to do is, I am going to import matplotlib.pyplot as plt. So this as plt is the alias name. So every time if you need to use something from this PyPlot, you cannot call the entire name, right? Matplotlib.pyplot, you cannot use it everywhere. So for that we are giving a short name as plt. So I'll import matplotlib.pyplot in that as plt. I'll run this. So now we can use this plt to call the Matplotlib and we can do the visualization part. So let's start. First let us understand what is the anatomy of a Matplotlib figure. So we can see many type of figures, right? So while moving on with this topic, we will be seeing about line plot, bar plot, histograms and so on. Okay, so many scatter plot and many types. So we'll be getting some figure as an output like this, some graph. So let us understand what is the anatomy of this Matplotlib figure. So this is the title, where you can set the title and you can set a minor tick, major tick. You can set the label, y label, x label, x axis values, y axis values, markers, the line, okay, type of the line, and you can place the grid also. You can place the legend which mentions what color it will represent. Okay, so this will be the general anatomy of a figure, Matplotlib figure. Starting with line plot. So line plot actually is used for visualizing the trend over time, such as stock prices or weather patterns or any other traffic website. You can visualize that, and they are often used in scientific research to plot data from experiments or simulations. So it can also used to compare two or more data series. Okay, so let us see. You can like separate it with different color and you can visualize in a single graph. We'll see about this line plot. First let us create an array and we'll do this. Okay, so to use this line plot, what you can do is you have to call dot plot from plt. So plt is nothing but matplotlib.pyplot, and in that I am calling plot. So this plot is generally mentioning the line plot, and you can either pass one value which is like only x or y or both. Okay, so let us pass this x and y and let us see what is the result. Okay, and let me go on into my Google Colab. In the variable x, okay, so now we are going to use numpy, right? So I'll import numpy as np Okay, we have already installed it, so now we can import it. Numpy as np, I'm going to use it here. So in the variable x, I'm going to call numpy to create an array. We see this, right? And in that I am passing 0, 50. Okay, and then in y I am creating another array and I am storing 0, 50. So these are the two values in both of these arrays. So let me call plt now, plt.plot, and in that I am going to pass x and y. And this plt.show is like printing option. Okay, in strings you will be print, right? So this plt.show will give the output. It will visualize, it will show the result. Okay, see here we got a graph. So in the x-axis the value starts from 0 and we are having a 50 value, right? So it extends till that. And in y also we got the same, and we got a straight line. Okay, so in the 0 x-axis we are having 0, on the y-axis 0, 0, and 50, 50 is marked, and then a straight line is drawn. So this is the line plot. This is a simple line plot. Similarly, you can also draw multiple line plot. Okay, you can also draw multiple line plot. So let's run this. So in the variable x, I'll create an array with multiple points, and in y, let me create another array So I am going to plot this plt.plot x, y, and let me show it plt.show. So this will contain multiple points. So the first point will be x-axis value is 1 and the y-axis value is 3. So we got the result here. And then next, the x-axis value, when it is 2, the value of y reaches 8. So we are getting 8 here, and it is connecting that line. And from that we are going in the point 5 in x-axis, we are having the value 4 in y-axis. So we are getting a point here, and we got this straight line. So this is how we can plot multiple lines. Okay. Next, you can also change the line style. If you set line style equal to dotted, it will change. So there are many options like dashed and dotted lines. You can change that. For that I can just give here line style, sorry, in small letters, line style equal to dotted. So this will change the line style. We'll get a dotted output. Actually this image you can copy it. Okay, you can copy and use it anywhere. See here, if I press right click, I can just copy the image and I can paste it anywhere. Okay, this is in an image format output. And the next, you can also set labels for x, y axes, and you can set the title. And if you want to visualize a grid, you can do that also. Let's start with visualizing a grid here. So let me copy all this, and if I wish to show a grid here, so I can call the plt to show the grid dot grid, and I have to pass a parenthesis here. So if I run this, I'll be getting grid in this diagram. So here we got a grid line. It will be easy for us to see which point where it is. Okay, so the 1 and 3 merge here, 2, 8 is here, 5, 4 is here, and then 7, 10 is here, right? So these grids will be useful for that. And if I wish to go on with mentioning the x and y axis, I can do that. If I need to wish to set the title, I can do that. To mention the x label, I can set plt.x label. I can set some string here, so this will be displayed in the graph. And plt.y label will set the y label, and plt.title will show the title. Let's try this. So all these things should be before this plt.show. Okay, the show will be like finally printing it. Please keep it at the end. So in between this, I can set the x label. This is x-axis. I am just setting it for an example. plt.y label. This is y-axis. I'll run this. See here, we got x and y axis name, right? So label, and if you wish to set the title, you can do that also. So in this, I'm going to set a title, plt.title, line chart, example graph, line plot. Let's set this to plot, line plot example graph. Okay, we got the title here and the label for x and y, and we got the grid here. Okay, next, moving on into creating subplots. So whatever may be the plotted, whether it is a, like later on we'll be seeing about box plot or histogram or pie chart. Okay, so whatever may be the plot, if you want to create a subplots inside this line plot, okay, if you want a combination of plots, the subplot is nothing but a collection of plot. Okay, so in one diagram you will be splitting into pieces and you will be having different images. So this is a subplot, and you can see this is entirely a single image and it is split into parts, and each of this part will contain another graph. Okay, each will have a separate graph, and you can create this subplot with the help of plt.subplot, and inside the parenthesis you have to pass three things. I'll explain it one by one. The first number, okay, it is representing the number of rows you are having in this entire image. So I have mentioned 2 here, which means I need 2 rows. Okay, we are having this row 1 and row 2, and the next one, number 3, represents the column, number of column. So I have mentioned here 3 columns. So this is the first column, this is second one, and this is third one. So this totally means it contains 2 rows, 3 columns, which means totally it is divided into 6 sections. So you can represent 6 in the different graphs here. So the next number, final number, will be the position. If I need these values to be plotted in the place of number 1, so I can pass 1 here, this will place it here, and if I pass number 2, it will be placed next to it, and then 3, 4, 5, 6. Okay, so 2, 3 is the rows and columns will be constant, and the numbers representing the position of it will be different. Okay, 1, 2, 3 here, then 4, 5, 6. So if I represent 6 here, this will be these values. These graph will be placed here in the 6th place. Okay, but see here, I have here mentioned only 1 row and 2 column, which means I will be having like these 2. Okay, only 1 row with 2 columns. So totally there can be 2 images, and I am plotting the first image with these values and second image with these values. So let's try this in Google Colab. In the variable x, I create an array x equal to np.array. So I'll create some numbers here, 1. So this is an array. In the variable y, let me create np.array. Okay, so next, so I need this image, so I'm going to create a subplot. So this image should contain what all it should be. It should be in 1 row with 2 column. Okay, and this value should be present in the first image. Okay, as a first image, so I have mentioned 1, 2, 1, and I'm going to plot at plt.plot. So I'm going to plot x and y, so I have mentioned it here. And then next, so in some other variable you can create also. So in a, I'm going to set np.array 3, and then in b, let me create the y-axis value for this subplot, and this is going to be 40. So now I'm going to set the subplot 1 row 2 column. This is the second image. Okay, and I'm going to plot this plt.plot a comma b should be plotted here, and then plt.show finally. Let's run this, and we'll get a single image which is separated into 2 columns, 1 row 2 columns, and the first values is placed in this first image and the second values is placed in the second image. Okay, so we got this image, right? This is how you can use subplot to create multiple plots. Okay, so based on the rows and columns, you set that much amount of image you can store. If it is a 3 row 3 column, which means you can totally store 9 images inside, or if it is 2 row 4 column, which means totally you can store 8 images inside, right? So that's how this thing works. So moving on into next plot, which is scatter plot. Okay, so from the scatter plot, like for other plots we will see dataset examples also. So starting with scatter plot. So what is a scatter plot? Okay, so scatter plot are often used in data analysis and machine learning to find patterns or relationship. Okay, and these can help us to visualize the clusters present in our data values or in the points. So if we can find the clusters in somewhere, so it should like see it seems like majority of like the values are related in that area, they are relatively similar in that way. So this is how you can plot a scatter plot. So you can call plt.scatter and you have to pass x and y values, so it will create a scatter point in the graph, and this x and y will combine and create a scatter plot. And if you wish to go on, like if you need some other points also included in the same graph, if you want to compare it, you can create that and like overlap with these image, so you'll get both of these in a single graph. We'll try to do it in Google Colab. So let me go into my Google Colab and create these variables. So in the variable x, I am creating an array x equal to np.array. So let me create some random numbers here. Okay, and then we need y points also. So the thing is here, both x and y should be of same length. Okay, so if you are passing here the values x is 10 values, then 10 number of y values should be present, otherwise you will be getting error. Okay, and to move on with, I'll change the values of y here. Okay, now I have created x and y. So I'll first check the length of it, whether they are equal or not. So length of x, and I'll also print and try to check the length of y. So if they are equal, then we are ready to go. So it seems like there is some extra values on x, so I can add some other value here in y. So I'll run this. So now it will be equal. So this is just for an example. Okay, if you are going to visualize it from a dataset, then no issue will be there. So to plot a scatter plot, you can call plt.scatter, and I'm going to pass the values x comma y to create the scatter plot, and I'll click plt.show. Okay, I'll run this. So we should get a scatter plot here. Okay, this is a scatter plot example. Okay, so the values corresponding in the x5, it is 99, so it is near 99. So it is arranged in ascending order. Okay, the value 2 here will correspond to 101, so it is here, and then again there is some other 2, and so this is how this thing works. Okay, and you will get scatter plots. So this will help us to identify, okay, these images, like these plots are near, okay, they are similar, and you can find clusters in these. And let us try to visualize this scatter plot from a dataset. And to load a dataset, I have uploaded, I will upload it here. Okay, I already have it here. I'll use pandas to load this dataset. Import pandas as pd, right? So I'll run it. So in the variable, okay, we have two dataset. One is a heart dataset, another one is diabetes. So I'll create the variable name in that name itself, heart equal to pd.read underscore csv. And I'll copy this path, I'll paste it here, run this. So let's visualize it. Our head function will give us the first 5 rows, right? It's loading. So we got the first 5 rows. Okay, these are the features, and we are now going to use the scatter plot to visualize some of the features. Okay, and what I'm going to do is, in this data set I'm going to use the cholesterol. I'm going to check the cholesterol value. I'm going to plot it in a scatter plot with age. Okay, the age and cholesterol, I'm going to plot these columns. So for that I'll just take these separately. So let's start with plt.scatter. We'll type it here itself, both the x and y. So what will be the x value? Okay, I'm going to plot x equal to, so I can set like this, x equal to, I'm going to call the variable name where I stored my data set. It is heart, H-E-A-R-T, heart dot. So in that, which column I need, I'm going to get the age column to store in x-axis. So age, and in that, okay, I'm going to pass some like condition here. So I'm going to set data dot target is equal to 1. So first let's give 0. So what does this mean? Okay, so I'm setting data target equal to 0. Data means, like, I'll change this. This is not data, this is heart. So heart dot target equal to 0, which means in this heart variable we are having a data set and there is a column known as target, and if it is 0, wherever it is 0, that rows will be selected, and that rows, the age column is separately selected now. Understand? We are getting the heart variable here, the data set. In that the target column, if it is 0, that rows alone is taken. Okay, target is the output, whether like heart disease is present or not. It is either 0 or 1. Okay, so whenever it is 0, we are selecting and getting the age of them. Okay, and in the y, what I am going to do is I am going to call the data set which is heart dot. Okay, I am going to select the cholesterol column, CHOL. And in cholesterol column, I'm going to get the same where like the target is equal to 1. Okay, target will be 0 here. So we'll be getting the zeros and we'll be plotting this. And there is some other features, like you can set the label here. Since you are going to plot multiple things here, you can set the label heart disease absent. So the 0 will be heart disease absent. And now what I'm going to do is I'm going to plot another thing. So I'm going to again call the plt.scatter. So in the x I'm going to store from heart dot the age, same age, but now I'm going to plot heart dot target. I'm going to set this to 1. So whenever it is 1, and in y I'm going to call the same cholesterol. So these column where the heart target is 1. Okay, and I am going to set the label as, so this feature is for the patient who was having heart disease present, right? And next, so let me give some title here, plt.title. So in that let me give age versus cholesterol diagnosis. Okay, and let me set the labels here, plt.label, x label. So the x-axis is age, right? So in the x-axis I am going to set this to age, and plt.y label, and I will set this to, let's set this to cholesterol. Okay, so let me get the legend also, plt.legend. So legend is nothing but it will tell you which color is which. Okay, we are getting two things, so it should show the color with the name. And finally plt.show, which is for printing or visualizing the image. So let me run this. I'll run it and explain you once again what is happening here. Okay, this is the scatter plot we got from our data set. So what is happening? The blue color is heart disease absent and the orange color is heart disease present. So it is giving in two colors. We are passing in the same image two things. Okay, like this. So here I have used only one, I have shown you. You can also overlap with another point, so it will be in different colors and you can visualize. Similarly, we are using it with the help of dataset. Okay, I am setting the label heart disease absent and heart disease present. So you will get the color what it is. So you can visualize this. Okay, there is outlier here, you can find that. And I will explain you once again. So in the X I am using age. Okay, and we are selecting the age wherever the target is 0, which means like the patient who don't have heart disease, their age we are selecting it in X, and in Y we are taking the cholesterol of them, and it is in blue color. Similarly, we are getting the patient who have heart disease. We are getting their age and cholesterol, and it is in orange color, and it is portrayed in this scatter plot. This is how you can use a scatter plot. Next, bar plot. Next, we will move on into bar plot. So, what is a bar plot? So, bar plot is used to visualize. Okay, you will get different bars height wise. You can compare how much level, numerical level, what it is. Okay, now we will see with this example how a bar plot is. Let me go into my collab. So, we will see this and then we will use our dataset also to visualize a bar plot. So, next I am creating np.array. I will create some names here, A, B, C and D, and in Y, so it is capital X. I'll change it to small, Y equal to np.array. I'm going to set some values here. Okay, so now to plot a bar plot, what you can do is you can call plt.bar. Okay, this will set the bar plot, and I'm going to pass x comma y, and we'll see the result now. plt.show, and if you run this, okay, this is a bar plot where you can see the value of A is around 3, so because we set this to 3, and the B is around 8, C is 1, and D is 10. Okay, so this is how you can, like, how much values or number of occurrences based on it you can visualize this, and this is how you can use a bar plot. Okay, similarly, if you wish to, this is vertical bar plot. There is something known as horizontal bar plot, and if you wish to do that, you can call bar h. So this will create horizontal bar plot. Okay, so we'll try to do this. So let me copy this. We have plotted this, right? So this is vertical, and now we are going to visualize it in horizontal way. To do that, I am going to use bar h, and if I run this, we will be getting horizontal bar plot. Okay, the x-axis here, and you can find the y-axis here, and this plot is now converted into a horizontal bar plot. Okay, this will be somewhat good, visually appealing. And now what we are going to do is we are going to use this bar plot, okay, with an example of a data set. So I'm going to copy one. I'm going to load this diabetes data set. We'll copy the path here. Let me create a variable diabetes equal to pd.read_csv. And let me paste the path here. I'll run this. Let us visualize the first 5 rows using the head function. Fine, this is a diabetes dataset where we are having the columns known as pregnancies, glucose level, blood pressure, skin thickness, and many values. And then finally we are having the outcome column, where the outcome column, the 1 represents the presence of diabetes and 0 represents the absence of diabetes. So now what we are going to do is we are going to use bar plot to show visually the outcome column. Okay, so we will be counting the values, like how many persons got 1 or how many persons got 0, which means how many people having diabetes and how many don't have diabetes. So for that, I am going to create a variable. Okay, so for now I am creating it in the name of NOS. So I am going to call the outcome column from the diabetes dataset outcome. And what I am going to do is I am going to use value underscore counts to actually see how much people present in 0 and 1. And if I try to print this, we can see that like 500 persons got 0, which means they don't have diabetes, and 268 patients got 1, which means they have diabetes. Now we are going to see this representation in visualization. So first understand this 0 and 1 are coming under NOS. In this variable they are index, and this 500 and 268 are values. Okay, I can actually print this, print nos.index. If I run this, we will get the index number 0 and 1 which is present there, and I can also print using nos.values. So this will give us the values which is present 500 and 268. So now we are going to pass the index value in the x and values of this in y, so that we can represent it in the bar plot. To do that, I am going to call Matplotlib plt.bar. Okay, now I am going to pass the x value is the variable nos, I'm going to pass the index for x, and nos dot values, I'm going to pass that in y. Next, let me use plt dot show now. I'll run this. Okay, we got a plot here. So this value is near 500, so which means the 0 here, and this is below, like between 200 and 300, right? Below, little bit below 300, 268. So now see here, there is no label in x and y, there is no title, and see here this y axis is little bit clumsy, right? We are having like decimal values. I just need zeros and ones. So this is the center value. See here, 1 represent this and 0 represent this, but I don't want it to be this much clumsy. So I'm going to use some properties here. Let me use plt dot title. Let me set a title here. Distribution of outcome. So let it be the title, and plt dot x label. So I'll set it as a diagnosis, and plt dot y label, and let me set this to count. Okay, and now these are all fine. Now see here, I need to change the ticks which is present in x, right? So let me call the plt and x ticks. So this will help us to set the x ticks. So I'm going to pass two things. The first one will be 0, 1, which is already present, and this will be the value which I'm need to like place there. So here I'm setting the label as 0 and 1 only. So now if I run this, please make sure you are like doing this before the plt.show. The plt.show should be in the end, so that you can like encounter all of this and incorporate and visualize it. So I'll run this now. See here, now we got the graph with 0 and 1 in x-axis. Similarly, you can go on with the y ticks also, it's possible. And we got a title, x and y label, right? So this is what a bar plot is. Then we'll try to see the next one is histogram. So histogram are very useful for visualizing the distribution of a data set, okay? And like you can like visualize a height distribution or weight distribution, you can pass that column. Let us try this. See here, we are having a random values in the x, and if you need to plot histogram, what you need to do is you can call plt.hist. So this will create a histogram, and the first one I am passing in the values which I need to plot. So I am passing x here, and there is something known as bins. Okay, so you can set the value of bins. So bins will represent like how much you want to segregate. Okay. Imagine if you are having 100 rows, okay, if you are passing some column known as age column, so it should create some bar with histogram, right? So if I need to split that into 10, okay, so I can set bins equal to 10, so that it will split the age in 10 and then it will plot the histogram. If I want it into, then I can give that bins equal to 2. We'll try to visualize it, and let's try this in column itself. Without seeing this example, we will use the data set, and let's use this age column. Okay, in the diabetes data set, I'm going to use the age column, diabetes, and in that age, I hope it's correct, capital A, fine. So let me run this. So this column contains age, and we are going to visualize this in histogram. So I just need to pass this here there. Let me call plt.hist. This will plot a histogram, and I'm going to pass the variable diabetes age. Now I need to mention the bin value. So bin is equal to, let me set this to 20 now. For now, let me run this with plt.show. I'll run this. See here, this is a histogram and it is split into 20 different things. Okay. If I change this to 10, you can see the difference. So it will segregate based on it. I can even set this to 4. So it will separate them into 4, okay, 1, 2, 3, 4. So this is what this histogram is, and this bin value is. And you can actually set the title here also, plt.title, age distribution, and plt.x label, age. And in y label we are having the count, right? run this. Okay, see here, now let us try to visualize it. So in this plot, in this bar, see here, it is around 35. So between this value 20 and 35, we are having maximum count of around 500 people. Okay, the remaining people are like there are around this age we are having this count, and above this 70 to 80 you can see here that much count we are having, it's very low, like similar like near to 20 or 30 like that. So this is how you can visualize using the histograms. Next, moving on into box plots. So box plot are used for visualizing the spread of a dataset, okay, like range, median, quartiles and outliers. So this is a blueprint of a box plot. So we need to understand that to like understand what it is representing. So in the center we are having a middle median value which is known as middle quartile, and we are having upper quartile and lower quartile which is like 25% difference from the median value, and above that 25 plus 25 will be the 50% values will be in the quartile 4 here, and another 50% will be here. We are having a lower whisker and upper whisker, and above this or below this will be the outliers which is like a very much difference from the center median value. Okay, this is what this box plot is. You can plot the box plot with the help of plt.boxplot, and you can pass the data inside, so this will create a box plot for you. Okay, we will try this in Google Colab. Let me go into the dataset. So in this dataset, now what we are going to do is we are going to use this age and outcome column, and we are going to visualize in box plot for the patients. Okay, the age of the persons who have 0 in the outcome and the age of the persons who have 1 in the outcome. Okay, we'll try to do this using box plot. So let me call plt.boxplot, and inside the parenthesis I'm going to create a square bracket, and we are going to give two things inside of this. First, let me call the variable name diabetes, and in diabetes, okay, I'm going to set a condition here where in the diabetes data set, in diabetes dot the column which is outcome, okay, if the outcome column, if it is equal to 0, I'm going to select that rows only first. So this will select only the rows which contains outcome column as 0, and in that I'm going to get only the age. Okay, so this will get the age for us, comma. Now I'm going to create another condition here. The second one will be diabetes. In that, let me give diabetes. So inside this diabetes, let me give the condition similarly here. In that, the outcome column, if it is equal to 1, okay, and their age. Okay, so next I'll close the square bracket which you opened here. It is ending here. Inside of this we are giving entire thing. Okay, next let us give the label also here. Labels equal to, first one will be no diabetes, and the next one will be diabetes present. Okay, so we'll try to learn this. We are getting some error here which is mismatch. So this one starting here and ending here, this one, right? So if I run this, it will run fine. So here, see here, we got this graph. Let me give the x and y labels first. Plt dot, if we set the title, age against diagnosis, and plt dot x label, let it be diagnosis, and plt dot y label, and let us set this to age. Okay, finally I'll try plt dot show. So now this will be altered. We'll visualize the graph and understand what the meaning of is. So we got age against diagnosis, so age column here, and diagnosis whether it is diabetes absent or diabetes present. And see here, you can find the median value here. The median value for no diabetes is around like below this 30, which is around 28 or something. And the average like median value for diabetes present is around 38 or something. Okay, so this is how you can use the box plot, and these are the outliers. We are having the upper whisker here, lower whisker here. this will like give us a representation, okay, the various distribution of the plots using this box plot. Fine. And please remember, we are inside this square bracket we are passing two things. First one will be no diabetes, second one will be diabetes present, and we are calling with the help of outcome column. If it is 0, we are getting the dataset dot age and dataset age if the outcome is 1. Okay, and we are setting the labels here and title X label, Y label. So that's it about the box plot. Next, pie chart. Okay, let us see how to do this pie chart. So pie chart are useful for showing the relative size of different categories. It will give what is the percentage of distribution among them. So we can do this with the help of plt.pie. Okay, this will, if you pass one thing, so see here we are having an array here which is like 100 is equally splitted, and if we pass y here, it will create a pie chart. Let's try this in Google Colab first. We'll try to plot this pie chart, and then we'll use our dataset to plot that. Okay. First, let us create a simple pie chart. plt.pie. Okay, and inside of this, I need to call np.array. Let us create this first. X equal to np.array, and let me create some values 25, 35, so around, then again 125 and 50. Okay. Now I run this plt.py. We pass x here, and let us call plt.show. Okay, this is a pie chart. These values are represented here, but it is like we don't have anything legend or what it is meaning, we don't know that, right? So for that, what you have to do is you have to pass the labels. So to set the labels, you can call labels equal to, you can set it here or you can set it previously with the help of square bracket. You have to pass it as a list, and then you can pass it here or you can type it here itself. So we are passing apples, bananas, cherries, dates, and you have to call the plt.legend to actually understand which color is which. You have to know, right? So for that, let me set here y equal to, let me set the labels here: apple, orange, kiwi, and banana. And here it should be before, right? So let me paste it here, comma, labels equal to y. Okay, and plt.legend. So let me run this, and as you can see, we got the legend with color. Right now we can understand the distribution. So orange, kiwi, banana. So banana is very least, as we know the banana value is 15 only, and the 25 value, which is kiwi, which is in green color, and then this orange and apple, the orange and blue ones. Okay, so in that orange is majority because it is 35. Okay, and we can find the kiwi and this 25, this is kiwi, and the apple is 25, right? The blue one, the blue and green one are equally distributed. The banana is the least and the most major is orange. Now we'll use this to plot it in our data set. We'll try to visualize the age again. We have counted the values, right? Sorry, we have counted the outcome, right? Here in this, the outcome column 500 and 268. Or else what we will do is we can call the age here. We are having the age in this hard data set, right? So we will call that and we will try to plot that in the pie chart. Okay, hard.age. Let us try to get this column. So now we are going to pass this, sorry, the outcome, right? Sorry about the age part. So we cannot plot the age in the pie chart, it will be very vast, and we can plot the outcome, it will be better. Here it is represented as target. Okay, so let me select that column, target. So we are having zeros and ones, so let us count the value here, HEART, heart, in that target column dot value underscore counts. Okay, we pass it here. So we are having 5261 and 4990. So now what we are going to do is, this is the index 0 and 1 and the values are 526 and 499. I am going to call plt.py, and in that we are going to pass the values here. So let me create and store it in a variable. no equal to this, and let me call the no dot values here, and the labels will be no dot index. Fine, let me run this. Let me set the title here, plt dot, we can get the legend also, and plt dot title. Let me set this to diagnosis. Finally plt dot show, and I'll run this. So see here we got the distribution between 1s and 0. 1 is majority because we got, when we try to print this, we got the 1 value majorly and the zeros are very less. 5261 and 499, which is around 50% right equally, so it is giving this. You can also get the percentage here. So if you want to visualize the percentage in this pie chart, what you can do is you can set the auto PCT, and I'll set this to percentage 1.1f. So this will represent in the 0.1 values, and then I'll pass the percentage here. So if I run this, I will get the percentage in between. See here we got only the decimal values I'm mentioning is 1.1, so it will mention only 1 point. So if you want like 3, 2, 1, like many decimal places, you can mention that here. So now it is representing 51.3% got diagnosis 1 and 48.7 got 0. Okay, you can actually change these labels without this index. Positive, which is 1, right, and this is negative, which means absent. So if I run this, so this is a distribution, okay, about positive and negative. That's how you can use this pie chart. So what is Seaborn? Seaborn is another library similar to Pandas, Numpy and Matplotlib. It is a popular Python library, and this is also used for visualization. Okay, in Python, Matplotlib and Seaborn both are very famous for this visualization, and this Seaborn library is built on top of the Matplotlib library. And this Seaborn offers a variety of functions to generate different types of visualizations like scatter plot, bar plot, heat maps, violin plots, and many others. We will see that one by one. Nearly 8 plots we will see about it. And we have Matplotlib, right? Why we need Seaborn and why it is built on top of it? So this is a high level interface for creating informative, and the main thing is Seaborn is visually very attractive. Okay, so it will show a very good attractive image. It will be very useful for us. So we'll see that how to use this Seaborn. Starting with the installation. To install Seaborn, you have to type pip install Seaborn. I'll go into my Google Colab with the exclamatory mark. I am typing pip install Seaborn. Okay, so I'll run this. So I already have the Seaborn, so it is telling requirement already satisfied. So the next step will be importing Seaborn. To import Seaborn, we are importing it entirely. Import Seaborn as in the short form SNS. So let me call it import Seaborn in the name SNS, right? I'll run this as SNS, import Seaborn as SNS. Okay, now we have loaded Seaborn in the variable SNS. Now let us see how to use it to plot, starting with scatter plot. Okay, so to draw a scatter plot in Seaborn, you can call sns.scatterplot. In Matplotlib we will be just calling .scatter, but here we will be passing .scatterplot, and you have to pass the x and y. So x, what is the x value? You can pass the name of the column name, and in y you can pass the column name which you want to plot in y, and the data you have to set the variable where you have stored your data set. Okay, so if you pass the data here, then no need to call the dataset dot column name. So you can just mention the name of the column in x and y, and you can pass the data equal to the dataset where you stored, and this will be very helpful. We see how to use the Seaborn. And in this, what I'm going to do is, Seaborn already has some sample datasets. Okay, with the help of Seaborn you can load some dataset, and it is very helpful for us to understand Seaborn. So let me load it. First I'm going to load a iris dataset about the flowers. So I'm going to store it in the variable iris. So see here how to import a dataset from Seaborn. You can call sns.load_dataset, and in the bracket you have to pass the keyword So Seaborn having iris dataset. So let me run this. This will load the dataset. This is like coming with the Seaborn itself, and I can see it with the help of iris.head. Let me run this, and this is the iris dataset. It is about flowers. We are having sepal length, sepal width, petal length, petal width, and the species of it. Okay, so there are different species present here. You can also get the info of it .info. Okay, so totally 150 values are present and about their data type. And now let us see about scatter plot using this iris head. Okay, sorry, using iris dataset. So to draw a scatter plot, I am going to call snet.scatterplot. Okay, now I have to pass x, y and the data. So in the x, I am going to pass the sepal underscore length. Okay, this is a scatter plot between sepal length and petal length. So in x-axis I am going to pass the sepal length, and in the y-axis I am going to pass the petal underscore length. Okay, and now we haven't mentioned the dataset name, right? So this will show error. To pass it, we are going to give the data equal to the variable where I have stored my dataset iris. So this dataset is loaded here. So it will take the sepal length and petal length, that columns now. Then no issues for us. If I run this, we will be getting a scatter plot. Okay, this is the scatter plot between the sepal length and petal length, and we can find some patterns here. This is a group of pattern, and here we can find a bunch of patterns and some outliers, right? So this is how you can use a scatter plot. But see here, it is like visually it is not that much not appealing. You can set some other way things also in this. And now what we are going to do is, this is a combination of like entire thing, right? Sepal length and petal length. Now I am going to split that with the help of species column. Okay, we'll get what is the unique values present in the species. Species dot value underscore counts. Okay, there is something known as Certosa, versicolor and Virginia. So these three species are present here. Now we are going to separate it like based on the species. Okay, so what I have to do is, I am going to set hue. Okay, there is something known as hue, and this hue equal to, I am going to set the species column as hue. Okay, so hue is nothing but for color encoding. Okay, based on color it will differentiate. Since species has three different unique values, we will be getting three different colors and their respective sepal length, petal length in the graph. I hope you can see the blue color is Certosa. Okay, it seems like they have like very little sepal length and petal length, and the middle value go to versicolor, and the Virginia has the longest sepal length and petal length, right? So we can see that with the help of this, with the help of this color differentiation. So hue is for color encoding. We have separated it with the help of hue, and also you can also set some other things also. You can set the size here. I'll pass the size. So size I am going to give the column, like let us separate it with the help of sepal width or petal length. So let me set it to petal width first, petal underscore width. I'll run this. So it is separated into these much values, 0.4, 0.8, 1.2 based on the size. So if it is the biggest dot, it is like petal width is 2.4, and if it is the smallest here, you can see it is 0.4. It is like differentiating with the help of this size also. Okay, this is how you can set this. There is also something known as set theme. Okay, whenever you are starting, you can set the SNS theme, SNS.set underscore theme. So there is, you have to mention the style here. There are styles like white. If I run this, this will set for the entire things. Okay, whichever graph we are creating, this is the white theme. You can set this to dark. There are some other themes also, you can check that in browser. So this is a dark theme. See here, we are getting the dark theme, right? Okay, this is how you can use the scatter plot here. There is also another thing known as palette, which will set the color here. Palette equal to, there are many color codes for here. I will set some other like few color code, rocket. So this is a color code. You see we got some different colors, right? And you can pass some other color codes also. I will pass the rainbow underscore R. I'll run this. So this is the color difference, right? So you can see that. So this is how about scatter plot. Okay, we have seen about passing the data, and we saw about the hue, which is like color encoding, and size for differentiating, and then palette and setting the theme for entire graphs. Okay, then moving on into bar plot. So to do a bar plot, you can call sns.barplot, and this will create a bar plot with x value, y value. You can set the hue here also. You can pass the data and palette here. Okay, let us see the bar plot now. So bar plot, why we are using it is represent categorical data with rectangular bars, right, where height and length are representing the frequency or count of the category. So it is useful for comparing the count or frequency. We'll try to do this in bar plot. Let me load some other dataset now. There is also the Titanic dataset is available in Seaborn. So I'll call sns.load underscore dataset, and let me pass Titanic name here. I'll run this. Let me give Titanic.head. Let us see the columns now. Okay, these are the column names, whether they are survived or not, passenger class, their gender, age, about siblings or parent, like parent, children, spouses present or not, then fare, embarked station, the class, and these details. Okay, so these are the things present. So now we'll do about the bar plot with the help of Titanic dataset. Okay, let me call sns.barplot, and in the bracket I'll pass the value for x will be the column 6, and in y I'm going to pass whether they are survived or not. Okay, so based on this I'm going to split that, and first let me give the data equal to Titanic. We'll see this first. Okay, it seems like most of the females got survived and male got like survived only less here. Okay, this is how bar plot works. It will give the count, you can understand, right? So we are not setting anything, this like we are passing the x and y values, and it is creating in very few lines, right? This is why we prefer Seaborn over Matplotlib. It is good for visualization and very easy. And I'm going to also set the color palette. I can set that palette equal to, let me set it to RDBU, it's red and blue. There are many palettes available, you can check that about Seaborn. Okay, now I can also set the hue here. Hue is for color encoding. Now we are having the male and female who got surveyed. Okay, that's what this graph tells us. Now I'm going to check this class column with the help of class column. Okay, in male surveyed, right? So male surveyed from like if first class is high or not, second class is high or not, which is the highest, which is the lowest. I'm going to see that for male and female in this class. Okay, using this class. So I just need to pass the hue here. So I can pass the hue equal to class. So this is for color encoding. It will split them with different colors. And you can see here, so we got legend here. So first class male got surveyed mostly, and in the female also the first class people got surveyed mostly. The second class surveyed then in both the places, and the third class also got surveyed, but it is very less, right, in both the cases, male and female. This is how you can use Seaborn and bar plot. You can pass the hue here. Hue is very easy, it is very important, so it can give you very visualizations very easily. You cannot compare, right? We are having this data set, you cannot see it one by one, but with the help of this plot, bar plot, you can see, like, right? So the persons from the first class only got survived majorly, and when comparison, female got survived mostly rather than male in this Titanic data set. Next, we will go on with count plot. So count plot is a graph that shows the count of occurrences of each categorical value, okay, in the data set. So it will give the count of that set. So we'll try to do it. So you can call sns.countplot. So the variable which you need to count, you can pass that, and you can set the data also. We'll use this count plot using this Titanic data set. sns.countplot. Okay, and here x I need to mention, right? So with the x I'm going to go and see my data set. Let me give the survived column. Okay, survived, and next I'm going to mention the data equal to Titanic. I'll run this. Okay, survived is nothing but whether they are survived or not, and it seems like 0 is like, you can see the count, right? This is what the count plot is giving. We got around more than 500 who got survived, and 1 is like not survived, and it seems like nearly 300 persons didn't survive. So this is what this data set is, right? So you can count that with the help of this count plot. You can pass the variable and it will give you the count of it. Okay, you can also check that with other things such as embarked. Okay, there is a embarked and there are many things. Let me pass the embarked here. It seems like 3 stations. Okay, 3 stations. Queensburg, I don't know exact name. It is like 3 different stations, and from S we got like more than 600 passengers. From C we got nearly 200, and in Q it is like less than 100 only, right? So this is how you can just pass the count plot. It will give like, it is similar to value underscore counts, but it is visually giving the answers. Next, moving on into box plot. We seen about the box plot in Matplotlib also. We'll see it here. You have to pass the x and y value and then the data where you are going to plot. We'll use the iris dataset for this. Okay, using the iris dataset, I'll again call iris.head. Okay, this is the dataset, and using box plot, sns.boxplot, I'm going to pass in the x, I'm going to plot the species, and in y, I'm going to plot the sepal width. Okay, and the data equal to iris. So I'll run this. So we got a box plot here, and you remember, I hope so, the middle line represents the median value. So based on the species, I am separating the sepal width of each one. Okay, it seems like the Setosa, the median width is around 3.4, and with versicolor we got like below 3.0, and with Virginia it is like above 3.0. Okay, this is how you can use this box plot. So box plot is like give you the distribution of the data set, whether it is minimum value, maximum value, median, outliers, quartile. You will get that using box plot, right? Next, we are going to see something new known as pair plot. So a pair plot is a graph that shows a pairwise relationship. So it will give a pairwise relationship between variables in the data set. Okay, for each column compared with other columns, you will get many graphs in this pair plot. So it is useful for identifying patterns or correlation between them. We will try to use this pair plot. To draw a pair plot, you can pass sns.pairplot. Okay, you can set the data and hue value. We'll try this. Let me call sns.pairplot, and in that I'm going to pass the data iris. Let me pass for iris first, and let's run this first. Then we will go for visualization, some other things next. So it's running, and you can see the different what it is. So it will give you a pairwise relationship. So how is the petal length related with sepal length? You can get a graph here. Okay, bar plot, and how the sepal length is related with the petal length, you can get it here. This is how you will get a comparative. Okay, you will get a comparative graph separated in as subplots. Okay, this is an entire plot. And another thing, whatever the plot you are drawing in Matplotlib or Seaborn, you can just copy or paste it anywhere. Okay, and this is how it will give a correlation between them. We will try to give palette. So let me set this to set 1. There is something known as set 1 palette, and I'll set a hue here. We'll try to separate it with the help of species. Okay, in species column I'm going to give the hue. So let us try to visualize it now. Okay, we are getting error. Set 1 is not a valid name. So let me remove this. We are having, these are the like names. Set 1 capital S, right? So you can see here, these are the like color values, palette names, different colors. You can set that, and I'll run this now. Okay, see here we got, based on the species we got different pair plots. How about this relationship? Okay, it shows a pairwise relationship, how each column is related with other columns. Okay, using different graphs, and it is visually appealing also, right? Next, let me zoom this, and we'll see about the next plot now. Next, moving on into heat maps. Okay, so heat map is using correlation. We are going to do that. So a heat map is a graphical representation of data where the individual values contained in a matrix are represented as colors. Okay, based on the colors it is represented. And when using correlation for this heat map, it shows the relationship between different columns, how one column is related with the other. Here we got different graphs, but in a single graph we are going to get a heat map. So a heat map is nothing but based on the color you can see the difference, and this heat map is composed of like the relationship between each columns. Okay, one column with the other columns. If the color is very warmer, it means a very stronger positive correlation is present, and if the color is weak, then we can understand there is a like very negative correlation is present between them. And there are many things here you can use regarding, like you can, to get the correlation first we have seen this in pandas, right? So the variable name where you have stored your data set you can call .cor. So this will create a correlation, a table, right? So I hope you remember, we'll see that also. So when we pass this in the heat map, sns.heatmap, it will create a heat map. And if you need color bar, you can set c bar equal to true, and the line width you can set that. And for annotation, if you need, annotation is nothing but the values which if the graph, if you need that, you can give annotate equal to true, and you can set the format of it also. And you can also set the color map, which is like for colors only. We'll see this in Google Colab. So for this we will use the iris. Okay, iris.cor. Let me run this. So this is the correlation 4 cross 4. We got how this is related with this and this column is related with this column. What is the correlation difference between them, right? You can also go for titanic.cor. Okay, how each column is related with the other column, what is the correlation, whether it is a positive correlation, what is the relation, that's what this correlation means. So what it is a positive correlation or negative correlation, we can get that. And let's try this now using heat map, sns.heatmap, and in the bracket let me pass this. Okay, Titanic first, let's plot for titanic.cor. Fine. So next I have to mention other things such as color map equal to true. Let me set that to true, comma, sorry, c bar equal to true, color bar, c map we'll set that later. What is the color bar we need? And line width, let me set this to 1, or let's set this to 2. And then if I need annotation I can set that to true. And format, let me set this to 0.1f. Fine. Next, let us set c map equal to, let's get this in blue colors. Okay, so blues. Let's run this. Okay, we got an error. Okay, I have to pass this here, parenthesis. So I hope it will be fine now, and we are getting the plot, right? So this is what a correlation matrix is. It is a heat map, and you can see the darker color is like 1. It is a like equally correlated because this surveyed is related with surveyed, right? Both are same. So we got 1 here, and the value like positive or negative correlation you can compare it here, right? So if you remove this not equal to false, if we set that to false, you won't get the values inside. See the graph now. I'll run it now. If I set this to false, you won't get the values inside. You will be just getting a heat map. Okay, I can set this to true, and I am setting the format is 0.1f, so we'll be getting values in 1 decimal points. We got right 1 point like 0.1 or 0.6, 0.3, 0.2, and color map. If it is not blue, you'll be getting different colors. And color bar is this. Okay, so if the correlation, if the color is this dark, then it is 1.0 correlation. So if it is very light, you can see, right, minus 0.2, minus 0.4, you can get the very white, like near to white colors. So line width, if I set this to 20, you can see the difference. It is like very different, right? So we are setting this to 2. So that's what the line width do. This is what a heat map is. Okay. Next, moving into dist plot. So what is a dist plot? We haven't seen that, right? So a dist plot is a graph that shows the distribution of the data set by plotting a histogram. It is like similar to a histogram with a kernel density estimate. Based on the density, you will getting histogram. It is useful for visualizing the shape and spread of the data and can help to identify any patterns which is present there. Okay, and to plot a disk plot, you can pass the variable here. So variable where you have stored your data set, or which is the like column you are going to visualize, you can pass that in this sns.diskplot. Okay, we'll try to do this. I'm going to load a new data set for this. Okay, I'm going to call sns.load_dataset. There is something known as tips dataset. I'll run this. Let's try to see this tips.head. It's a new dataset. We haven't seen that. So it is about like a hotel dataset. What is the total bill? What is the tip they are giving? And who is it? Is male or female? Whether they are smokers or not? It is daytime or nighttime? Okay. Oh, sorry. Day is like whether which day, Monday or Tuesday, Wednesday, something like that. And time, it is dinner time or breakfast. And size, we are getting this, right? So now we'll try to do the disk plot using this sns.diskplot. So I'm going to call the total bill here. Okay, I'll store in tips, right? Tips.total_bill. Let me pass this column. I'll run this. Okay, we got a histogram. Okay, based on the difference, we are getting the histogram, right? And it seems like what is the density and total bill value. So if the bill value is this much, so we are getting the like what is the most people are getting, right? So that's what this disk plot does. Okay, you can pass other things also, like the tips column here, tip, right? Okay, this is a tip value and their density. Okay, next moving on into violin plot. So let us see what is a violin plot. So why that name, you'll understand that a violin plot is a graph that combines the information of a box plot. Okay, it is similar to a box plot with a kernel density plot, but it shows the distribution of the data in terms of the density. Based on the density we'll get, okay, and it is like similar to the shape of the violin. We'll see that, and it is useful for detecting patterns and outliers based on it. We'll see that. So to visualize a violin plot, to plot that, you can call sns.violin plot. So you can pass the x and y and the data set you are going to use. We'll use this tips dataset to see that. Okay, again let me call the tips.head. I'll run this, and you can call sns.violin plot, and we'll see why it is named as violin plot. And in the x I'm going to pass the day column, and in y I'm going to pass the tip. Okay, we are going to compare the day and tip value. So based on which day we are getting most, you can see that, and the data set we are going to use is tips. I'll run this. Okay, this is similar to violin, right? So we are getting the violin plot, and in Thursday, Friday, Saturday and Sunday are the columns here. Okay, are the values, and this, okay, we are getting the center value here. I hope you can see the white dot is the median value. We are getting the median, right? In case of we got it in the box plot, similar to it, we are getting here the middle values in the white dot, and these are the like most like went away, and you can see the density is high here. We are getting these areas are like most dense. Okay, you can find it in all the points, right? You can set the palette also. You can change the palette and like these things. Okay, this is how you can use a violin plot.